Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on Norton's theorem and its related problem. So first I will state Norton's theorem. So first, any linear network consisting of number of voltage sources, current sources and resistors are replaced by single equivalent circuit. That single equivalent circuit consists of 1 volt, 1 current source in parallel with resistance. Here in the Thevenin's theorem states that in a linear network containing number of voltage sources. Here this is one linear network. All elements in the network must be linear. Here resistors, inductors, capacitors are the linear elements. Here in a linear network consisting of several energy sources. Several energy sources means here either voltage source and current sources, and resistors are replaced by single constant current source in parallel with single resistance. This circuit is replaced by single equivalent circuit. That single equivalent circuit consists of current source, constant current source, single current source, current generator, that means current source, and its single resistor. This circuit is replaced by single equivalent circuit. That single equivalent circuit consists of one current source in parallel with resistance connected across the load terminals. Now here this current source is known as IN and this resistance is known as RN. IN means Norton's current and RN indicates Norton's resistance, and RL is the load resistance in which current is to be calculated. Now here how you will calculate this IN? So IN and RN can be calculated. RN can be calculated, remove the load resistance from a given circuit and short the voltage source and open the current source and calculate the R equivalent. That R equivalent is known as the Norton's current. First remove the load resistance from a given circuit. So first suppose it is a load resistance R3. R3 is the load resistance in which current is to be calculated. So R3 is known as the RL. This is the load resistance. Here RL is the load resistance. RL equals to R3 is the load resistance. First remove the load resistance from a given circuit and voltage source is replaced by short circuit, and if any current source is present in a network, that current source is replaced by open circuit, and calculate the all voltage sources are replaced by short circuit, shorting the all voltage sources and opening the all current sources. Here all current sources are replaced by open circuit and calculate the R equivalent. That R equivalent is known as the RN. So that is R equivalent here. Now how we will calculate the IN? Same thing here, remove the load resistance from a given circuit. Here remove this load resistance and short this load terminal and calculate this short circuit current, and that short circuit current is known as the IN. So see the steps here. So find out the IN. IN, remove the load resistance from a given circuit and short the load terminals. This load resistor is replaced by short circuit and short the load terminal and calculate the short circuit current. That short circuit current is known as the ISC, is known as the IN. This ISC is known as IN. That is, this is short circuit current across the load terminal. Now here let us take one problem. So here from this, here IRL equals to, that is IR3 equals to this current. So for this particular circuit using Norton's theorem can be calculated. Here this is total current. Here current division you can apply here. Current, what is the current division formula? Two parallel branches. Here two parallel branches RN and RL are connected in parallel, and here the total current is the IL. Now here according to the current division rule, here we need this RL branch current IRL equals to this load resistance IL current equals to opposite branch resistance, this RN divided by total resistance RN plus RL into this total current is IN. So here two resistors are connected in parallel, and that R1 and R2, and total current is IT. So for that particular case we can obtain the currents, individual branch currents, individual resistor currents. So here is the formula to calculate the load resistance. In this way, we can calculate the current flow into the any element in the network using Norton's theorem. Now here in the first problem, same already these problems we solved in the Thevenin's theorem. Same problems I am taking here. So for the verification purpose, I will solve each problem. So already which are solved in the Thevenin's theorem, same problems. So here we will get the same answer. So just compare with that Thevenin's theorem problems. So see the Thevenin's, if you solve the Thevenin's theorem problems, then you will get some idea how theorem is verified. Now here first determine current flowing through the 100 ohms resistor using Norton's theorem. Here current flowing through the 100 ohms resistor. This problem we solved in the Thevenin's theorem. This current equals to 0.48048 milliamps. So that we verified also in the Thevenin's theorem with mesh analysis. But here we are calculating using Norton's theorem. So here we are how you will calculate this from the Thevenin's theorem. First over here, so that this can be replaced by the circuit can be replaced by single equivalent circuit. This single equivalent circuit consists of a current source in parallel with resistors. So what is the difference between Thevenin's theorem and Norton's theorem? Only the difference is their current source. Here current source, over here current source in parallel with resistance. In the Thevenin's theorem, voltage source in series with the resistance. Everything remains same. Now here IN you need to calculate and RN you need to calculate. Then you can, here RL equals to directly 100. Now this is the load resistance. First determine the load resistance here. First IN can be calculated. First remove the load resistance from a given circuit. First I will draw the circuit here. This is the circuit. First remove the load resistance from a given circuit. 82, 47, 150 and 100. This is 15 volts plus and minus. Now here for what are the steps to calculate the Norton's current IN? So first remove the load resistance from a given circuit and short this load terminal and calculate the short circuit current. That short circuit current is the IN. Remove the load resistance from a given circuit, short the load terminal and calculate the short circuit current. That short circuit current is known as the IN. Now here this short circuit current IN. Now how you will calculate? By using mesh analysis. By any circuit analysis method you can calculate. You can use nodal or mesh. Here I am using the mesh analysis. Here how many meshes here? 1, 2, I1 and I2 here. Now if you apply KVL in a mesh 1 and mesh 2, so mesh 1 current 15 minus 82 I1 and 100 I1 minus I2 here, and I1 and I2 are the mesh currents. If you simplify this, what will be the equation 1 here? 232. 82 plus 150 is 232 I1 and minus 150 I2 equals to 15. This is equation number 1. Next, second mesh equation, if you apply KVL in the second mesh, in that case, so 150 I2 minus I1, 47 I2 equals to 0. Here there is no 100 ohms resistive drop. Here we remove the load resistance and short the load terminals. The short circuit voltage is 0. There is no resistive drop across the 100 ohms. That is replaced by short circuit 150 I2 minus I1 and 47 I2 equals to 0. Now the simplified equation, minus 150 I1 plus 197 I2, that is 150 plus 47 is a 197 I2. I1 equation number 1 and equation number 2. If you solve this, you will get I1 and I2. Here we need I2 current only. Here the short circuit current we need here. While calculating the IN, we need short circuit current. That short circuit current is here I2 equals to 0.096. That means 96 milliamps. So that 96 milliamps means that is Norton's current. This is the short circuit current. Short circuit current equals to I2 equals to, that is IN, not Norton's current. You can substitute in the single equivalent circuit. In that IN you can substitute. Now calculation of RN. How you will calculate the RN? Same thing. What are the steps? Remove the load resistance from a given circuit, short the voltage source and open the current source and calculate the R equivalent between open circuit terminal. Then that R equivalent is known as a Thevenin's Norton's resistance. Same thing as we discussed in the Thevenin's resistance. So here RTH, RN both are same. That is R equivalent. Now first this one, same thing. So first remove the load resistance from a given circuit. This is 82, 47, 150 and this is the 100 and this is the voltage source. And first this one is a 100, actual given circuit 15 volts. Now remove this load resistance, step 1, remove the load resistance and short this voltage source. This voltage source is replaced by short circuit and calculate the R equivalent between open terminals. So what are the elements, what are the resistors connected in parallel? These two are connected in parallel and again in series with the 82 and 150 are connected in parallel. Next 47 ohms resistor is connected in series with this equivalent circuit 82 and 150 parallel connection. Now see, if you simplify this one, this value equals to 100.048. That is R equivalent. That means R equivalent is 100.01. That is RN. That equals, this is 0.096 and this one is 100.048. Now this is 100. If you apply current division rule for this circuit, or if you use this circuit, RN by RL plus RN into IN, that equals 0.048. Same thing we got here, 0.096 into, this is IN value, this IN value, and this is 100.048 divided by 100 plus RL value, this one 100.048. So now here this is 0.048 ampere, that is 48 milliamps here, 48 milliamps. If you use Thevenin's nodal mesh, any method, so any method you can use, if you use any method, you will get the same value, that is 0.048 ampere, 48 milliamps. That means. Now, second question here, calculate the current flowing through the 3 ohms resistor using Norton's theorem. Now, same related problem. Here, this current flowing through the 3 ohms resistor. Here, RL equals to 3 ohms. Now, this circuit is replaced by single equivalent circuit. That single equivalent circuit consists of current source in parallel with resistance. That current source is known as IN and that resistance is known as RL. Now here RL equals to, directly you can, what is the value here? This is the RL. RL equals to 3, in which current is to be calculated. Now here first step, if you know the IN and RN, then you can calculate the current flowing through this 3 ohms resistor RL current. Now first over here IN calculation, here find out the IN Norton's current. First remove the load resistance from a given circuit and short the load terminal and calculate the short circuit current. First draw the circuit. This one. Remove this load resistance and short this load terminal 25420. Remove this 3 ohms resistor and short this load terminal. Calculate this short circuit current. The short circuit current is known as IN and substitute in the equivalent circuit in this here. Now, if you apply KVL, if you use mesh analysis, you can calculate 1, 2 meshes here. Mesh 1 current I1, mesh 2 current I2 in clockwise direction. And if you apply KVL in the mesh 1, that one is 20 minus 4I1 and 5I2. This is rising voltage minus 4I1 and 5 into I1 minus I2. Now, what will be the simplified equation? 9. 4 plus 5 plus 4 is 9 and minus I2 equals to 20. This is equation number 1. If you apply KVL in the second mesh, KVL means algebraic sum of total voltages in a loop equals to 0. That here 5 into minus I2 minus I1 minus 4 I2 equals to 0. 5 into I2 minus I1 equals to 0 minus 4. Now here this 5 plus 2 is 7 and this is minus I1 equals to 0. Now this is equation number 2. If you solve these two equations, equation number 1 and equation number 2, I1 equals to 3.69 and I2 equals to 2.63. Here we need I2 current only. Here I2 current equals to a short circuit current. That short circuit current is known as the Norton's current. That equals to 2.63. That is 2.63. You can substitute here. That is in amperes. Now RN calculations, Norton's resistance calculation, same steps you follow that one. First one, remove the load resistance from a given circuit. Same thing, remove this load resistance and voltage source is replaced by short circuit and calculate the R equivalents. What are the elements here? 2, 4, 5 and 2. Remove the load resistance from a given circuit. This 3 ohms resistor is removed from the given circuit and this voltage source is replaced by short circuit. And calculate this R equivalent. This R equivalent is known as the RN. This 4 and 5 are connected in parallel and this 2 ohms is again connected in series. 4 and 5 are connected in parallel means if 2 resistors are connected in parallel, in that case 2 resistors R1 and R2. In that case R1 into R2 divided by R1 plus R2. That is the condition for parallel connection equivalent circuit. R1 equals to 4 and R2 equals to 5. Again, in case of series connection, you can add the equivalent resistance to get equivalent resistance. 2 ohms is connected in series. Now here the final equation, what will be the value? Here the value of Rn value equals to 4.22. So that R equivalent equals to 4.22, that is Rn. Now that equals to 4.22. Now here we got the IN and RN and R3. Now you can substitute. You can use current division rule. So if you use current division rule, you can here same thing. RN, the total current, 2 branches RN and RL are connected in parallel and IN is the total current. So here we need the RL current. RL means IRL current means load resistance current equals to RN by RL plus RN into IN. Total resistance, opposite branch resistance divided by total resistance into IN, that equals to 1.53. That equals to 1.53 amperes here. That equals to 0. This value equals to 4.22 divided by 4.22 plus next this 3 ohms. This is RL into next 2.63. This equals to 1.5. If you use mesh, nodal and Thevenin's theorem, you will get the same value 1.53. If you use I1, I2, you will get the same value, that is 1.53. This I2 current should be 1.53. Current flowing through the 3 ohms resistor is 1.53. Now third problem. Calculate the current flowing through the 2 ohms resistor using Norton's theorem. Now see the circuit here. 4 ohms, 2 ohms, 1 ohm, 28 volts, 7 volts. Here, two sources are given. Now calculate the current flowing through the 2 ohms resistor here. I 2 ohms resistor. Now here, right here, I 2 ohms, I suffix 2 ohms resistor. Now here, how you will calculate the 2 ohms resistor using Norton's theorem? This circuit is completely replaced by single equivalent circuit. That single equivalent circuit consists of current source in parallel with resistance across the load terminals here. Now here IN and RN calculation. IN calculation can be calculated first IN calculation. First remove the load resistance from a given circuit. This is the load resistance. Here RL equals to 2 ohms resistor. This is RL. Now here this is 7 ohms volts and this is 28 volts. 7 volts and 28 volts. This is 4 ohms, 1 ohm and 2 ohms resistor current. 2 ohms is removed. And remove this load resistance and short the load terminal and calculate the short circuit current ISC, that short circuit current is known as the IN. Now, how you will calculate the short circuit current, Norton's current, by applying any method, nodal mesh, any method you can use here. I1, here mesh analysis I am using mesh 1 and mesh 2, here two number of meshes here, over here, and assume the mesh currents I1 and I2 in clockwise direction. And if you apply KVL in the each mesh, that first equation, that is 28, this voltage is 0. Now algebraic sum of total voltages in a loop equals to 0 according to the Kirchhoff voltage law. Now 28 minus 4I1 equals to 0. You can easily, you will get I1 equals to 7. Here I1 equals to 7. So 28 by 4. I1 equals to 28 by 7. And 28 by 4 means, that means 7. Now second, if you apply KVL in the minus 7, this short circuit drop is always 0, and this 1 ohm resistor. Next, I2 equals to minus 7. I1 and I2 we got. Now here I1 and I2 are the mesh currents only. Here we need this short circuit current. How you will calculate this short circuit current? So if you apply KCL, then you can easily, this is the I1 and this is the I2 and this is the ISC. And so what are the entering currents? Entering current is the I1 and leaving current is short circuit current. And next I2 current is the leaving current. Sum of entering currents at a node equals to sum of leaving currents. Now here ISC equals to I1 minus I2, that equals to 7 minus of minus 7, that equals to 14. So the short circuit current equals to 14. Next, Rn value. Rn value is calculated, same thing here. Now remove the load resistance from a given circuit. First I will draw the circuit. 4 ohms, 1 ohm, 7 volts and 28 volts. Now here remove this load resistance and calculate the R equivalent. Remove this load resistance and voltage source is replaced by short circuit, and current sources are replaced by open circuit. Here there is no current source, only two voltage sources are present, and these voltage sources are replaced by short circuit. Remove the load resistance and calculate the R equivalence. So how you will calculate this R equivalent value for this circuit? So 4 and 1 are connected in parallel, not in series. If they are connected like this, so these two are 4 and 1 are, if between these two, okay. But here this terminals, so this should be here and this should be here. These two are connected in parallel, so not in series connection. So this should be, now here 4 and 1 are connected in parallel, means R1 into R2 divided by R1 plus R2. Two resistors R1 and R2 are connected in parallel. So R1 into R2 divided by R1 plus R2, that equals 4 into 1 divided by 4 plus 1, that equals to 0.8. 4 by 8. 4 by 5 means that is 0.8. Now this is 0.8. Now we have IN and RN and RL value. If you apply current division rule, then you can easily solve this one. This one, IL equals to RN divided by RL plus RN into IN, that equals to, that RN equals 0.8 upon 0.8 plus 2 into, and this value is 14. This value is directly, that is 4. That means 0.8 divided by 2.8 into 14. Now here 8 divided by 28 into 14, that is 2 into 2, that equals to 4 ohms. 4 amperes here. I2 ohms resistor is 4 amperes. Here this current equals to 4 ampere, 4 amperes. Here current flow into the 2 ohms resistor. If you use Thevenin's and mesh analysis, nodal analysis, you will get the same value. I1 and I2, mesh analysis, I1 minus I2 should be, must be 4 ampere. Now next question. Calculate the current flowing through the 2 ohms resistor using Norton's theorem. Now here, how many sources here? Total 3 sources, 40 volts, 20 volts and 10 volts, 5, 10, 2. 5, 10, 2. 3 resistors and 3 voltmeters. Here, where you want to find out the current, here current flowing to the 2 ohms resistor current. So now what is the load resistance value here? 2 ohms resistor. Now here this circuit, complete circuit is replaced by single equivalent circuit. That single equivalent circuit consists of current source in parallel with resistance. That IN and RN. Here RL equals to 2 ohms current, 2 ohms resistor. This 2 ohms resistor you need to calculate. This current and this current must be same. If you use Thevenin's and mesh analysis, you will get the same way. So what are the steps you have to follow here? IN, same thing, that steps I will follow. First, Thevenin's also we calculated here. This one, this is 40, 5, 20 volts and this is 10 ohms and this is 10 volts. So first, remove the load resistance from a given circuit. Step 1, while calculating the Norton's current IN. So first, remove the load resistance. Remove the load resistance. If there is a 2 ohms resistor, remove that load resistance and short the load terminal and calculate the short circuit current. That short circuit current is known as IN. So how you will calculate this ISC, I1? So by applying mesh analysis, you can calculate the ISC. Here, how many number of meshes here? 1, 2, I1 current and I2 current. These are the mesh currents I1 and I2 in clockwise direction. Here I2 current, if you solve this mesh equations, then you will get the I1 and I2. I2 current is ISC current, that is the IN. Now here, if I apply KVL here, according to sum of algebraic sum of total voltages in a loop equals to 0. Now 40 is the rising voltage and 5 into I1, that is minus dropping voltage, and minus 20, this is plus to minus is minus, and minus 10 I2 minus I1, not I2 minus I1, I1 minus I2. If it is a plus, that is I2 minus I1. Now here, if you apply KVL, if that is the simplified equation, so 10 plus 5 is 15 and minus 10, and 40 minus 20 is a 20 equals to 20 plus 20, that is equation number 1. Now here in the second mesh equation, if you apply KVL, this is short circuit. There is no resistive drop of 2 ohms resistor. It is removed from the circuit and replaced by short circuit. That short circuit voltage is always 0. Now minus 10 I2 minus I1, same thing here, I2 minus I1 plus 0 plus 10 equals, this is from current is flowing from minus plus to minus, that is plus 10 equals to 0. Now the simplified equation, minus 10 I1 plus 10 I2 equals to 10 volts. So now here you can write this one, I1 plus I2 equals to 1. Now this is equation number 1, and if you can take any one, I1, 1 and 2, these two are same, so you can take any one. Now here, if you solve these two equations, you will get this one. So I1 equals to 6 and I2 equals to 7. So now here I1 equals to 6 means this current equals 6 and I2 equals 7. So what is the short circuit current here? This I2 current is the short circuit current. This is the I2 equals to I short circuit current, ISC, that is the Norton's current, that equals to 7. This Norton's current equals to 7 amperes. Now Norton's resistance, same, first follow the steps here. So remove the load resistance from a given circuit. First draw the circuit here. Now this is 2 ohms resistor and this is voltage source 10, 20, 5 and 40, and this one is 10 volts. Now here remove the load resistance first. Remove the load resistance from a given circuit. All voltage sources are replaced by short circuit. This voltage source, there is no voltage source here. There is a voltage source that is replaced by short circuited, and this is replaced by short circuited. This should be replaced by short circuited. Now here this should be replaced by short circuited. And here what are the resistors? And only these two resistors. There is no 40 volts. Each voltmeter is replaced by their internal resistance, that is replaced by short circuit. That internal resistance is 0 for voltage source, and for current source is internal resistance is infinity, that means open circuited. Now here this value is 10 volts. Now here find out the Rn. So 5 and 10 are connected in parallel. 5 and 10 are connected in parallel. Now in that case 5 into 10 divided by 5 plus 10, that equals to 3.33 ohms. Now here 3.33 ohms. Now we have Rn, In and RL. Now how you will calculate this RL, IL value? So from the from the current division rule here, Rn is opposite branch resistance, and RL plus Rn into In is equal to 4.38. Now here this current equals, this is 3.33 opposite branch current, and this is 2 plus 3.33 into 7, that equals to, this one equals 3.33, 5.33 into 7, that equals to 4.38. In the Thevenin's theorem, in the mesh analysis, we got the same value. In the superposition theorem also we have first you can check you can find this problem by using superposition theorem, by using Thevenin's, by using mesh analysis also. In the superposition theorem we verified with mesh analysis. In all theorem from the mesh, superposition theorem and Thevenin's theorem and Norton's theorem, that value, this problem I taken common here. I solved this problem Norton's, Thevenin's, superposition theorem and mesh analysis. In all the cases this value is 4.38 amperes. 4.38 amperes, 375 in the superposition theorem. Now next problem. Calculate the current flow into the 2 ohms resistor using Norton's theorem. So see the circuit here. 2 ohms resistor is here. 2 ohms resistor is connected here. This you need to calculate here. Now here, so the circuit is replaced by current source in parallel with resistance. Here this current source in parallel with resistance and connected across the load terminals. Here In and Rn. Here RL equals to 2 ohms resistor. Now here In calculation. First draw the circuit. Calculate the circuit. 2 volts and 4 volts and 2 ohms, 1 ohm, 1 ohm, 3 ohms and 12 ohms, and this is 2 ohms. First, remove the load resistance from a given circuit. Step 1. And short the load terminal and calculate the short circuit current. So that short circuit current is known as the In. Here In means how you will calculate the short circuit current, Norton's current, by applying mesh analysis. Now here possible number of meshes here. This is through 3 loops, 3 meshes network, 1, 2, 3 meshes here. That currents are I1, and I2 and I3 in clockwise direction. Now here apply KVL in the mesh 1. So 2 into I1, 2 minus I2 I1 minus 12 I1 minus I2 is equals to 0. And say the simplified equation 14, 2 plus 12 is 14 I1 and minus 12 I2 is equals to 2, that is equation number 1. And second equation minus 12 I2 minus I1 1 I2, this is short circuit. Short circuit voltage is 0 plus 0. There is no resistive drop, that means 2 ohms resistive drop, that is replaced by short circuit. And second equation is minus 12 I1 plus 13 I2. 12 plus 1 is 13 and this is minus 12 I1. Next, third equation, this value is 0. This resistive drop is 0. Minus 3I3 minus 4 equals to 0. Now, if you solve these two equations, that this is 0 I1 and 2 I2. 2 I2 plus 5 I3 equals to 0. This is 0. This is 0. This is 3 I3 only. Now solve these three equations. There is a wrong here. So here there is no impact of, there is no 2 ohms resistor. So this value is 0, I2. And this is 3, not 5. Now here I1 equals to 0.68 and 0.063 and minus 1.33. Now here, what is the short circuit current? ISC equals to I2 minus I3, that equals 0.63 minus of minus 1.33. So now the value is here, IN equals to 1.97. You can add this 1.33 plus 0.63, that equals to 1.97, this value. This is amperes. So 1.97 amperes here. Norton's current, that is short circuit current. This is IN. Now calculation of I1 calculation of the RN, this one. So this RN equals to same thing here. Remove the load resistance from a given circuit. First I will draw the circuit. Two ohms, 12 ohms, 1 ohm and 3 ohms and 2 volts and 4 volts. So this is 2 ohms. 2 ohms is a load resistance. Remove this load resistance and voltage sources are replaced by short circuited and current sources are replaced by open circuited. And this is replaced by short circuit and this is replaced by short circuit, and calculate the open circuit voltage, that R equivalent is known as the RN. Now here what are the resistors? These two are connected in parallel. These two are connected in parallel, and 2 and parallel with 12 and again in series with 1. So this you simplify it after that in parallel with this 3 ohms resistor. So see this 2 and 12 are connected in parallel. Next again in series with 1, and this entire circuit is connected in parallel with the 3 ohms resistor. Now the simplified equation 1.43, that equals to 1.43. Now how you will calculate this? This current equals to IL equals to RN, opposite branch resistance, by total resistance into IN, that equals to 0.082. So this IRL equals to, that equals to I2 ohms resistor equals to 0.082. This is 1.97. This is total current IN, and this RN is 1.43 into divided by 1.43. This is RN plus 2 equals to, that equals to 0.82. This is this here, and this current is 0.82 and 0.82. Thevenin's theorem also we got the same value. You can verify that. Next, calculate the current flowing through 10 ohms resistor using Norton's theorem. So first, 10 ohms resistor here. Current flowing through 10 ohms is a load resistance. RL equals to 10 ohms resistor here. Now here, first what are the elements here? 10 amps and 100 volts and 4 resistors, 5, 10 and 20, 30 ohms resistors are here. Now here only one current source is present and one voltage source is present. So now the circuit is replaced by IN and RN that is connected across the load terminal. Here IN and RN, this RL equals to 10 ohms and this RL equals to 10 ohms and this current flow into the 10 ohms you need to calculate here. Now IN can be calculated. First IN equals to, first draw the circuit. This is the current source 10 ampere and this is 5 and this is 20, this is 10 and this is the 30 and this is the 100 volts, 20 ohms. Now first remove the load resistance from a given circuit. How you will? So this is remove the load resistance from a given circuit and short the load terminal. So this 10 ohms resistor is replaced by short circuit and calculate the short circuit current. How you will calculate? So by applying the mesh analysis or nodal analysis. Now here the short circuit current can be calculated. First mesh 1, mesh 2, mesh 3. 3 possible number of meshes in a given network. And so mesh currents 1, 2, 3, I1, I2 and I3 are connected in I3 are in clockwise direction. Now here if you apply KVL, so here I1 equals to 10. Here this current source is value is the I1 current because both are connected in both are in same direction, so you can take plus 10. If one is in downwards from top to bottom and other one is loop current is from bottom to top, that is you can, at that case you can take minus. Next, second loop equation, apply KVL 5 into I2 minus I1. This resistive drop is 0 and 20 I2 minus I3, that is minus, total completely equals to 0. And the solution for this minus 5 I1 plus 5 plus 20 is 25, this one, and 20 I3 minus 20 I3. So next, if you apply KVL in this 20 I2 minus I3 minus I2 and 30 I3 and minus 100 equals to 0. The simplified equation, what will be the equation? 0 I1 minus 20 I2 plus 50 I3 minus 100. Now solve these three equations. I1 equals to 10 as it is, this one, and I2 equals to 0.58 and I3 equals to minus 1.76. Here we need I2 current only because here we need the short circuit current. I2 current is the short circuit current. Here I2 equals to short circuit current equals to and IN, that equals to 0.58. 0.58. Sorry, not here. 0.58 amperes. Now the calculation of this is IN equals 0.58 and calculation of RN. RN can be calculated. First, remove the load resistance from a given circuit first. This one current source and this is not here, and this is 5, 10 and this is 20, 30 and 100 volts and 10 amperes. So now here remove the load resistance from a given circuit. So calculate the R equivalent, but here voltage source is replaced by short circuit and this is 30, this is replaced by short circuited and this current source is replaced by open circuit. So it should not be short circuited. Voltage source is replaced by short circuit. Remove the load resistance from a given circuit here, and voltage source is replaced by short circuit and current source is replaced by open circuit. They calculate the R equivalent between these two terminals, and here 20 and 30 are connected in parallel. These two are connected in parallel, again in series with 5. The simplified equation, that is 20 into 30 divided by 20 plus 30 plus 5 equals to 17. This value is 12 and 12 plus 5 is 17, and this is 17. Now the simplified equation, this current equals to, if you apply current division rule here, so opposite branch resistance divided by total resistance into IN, RN divided by RL plus RN into IN equals to 0.3. That equals, if you substitute here, that equals to RN equals to 17 divided by 10 plus 17. 10 plus 17 into this 0.58, that equals to 0.37. This value is 0.37 amperes current flow into the 3 ohms, and 0.38 is this much, 37, sorry, this one, and this is 0.37 amperes. Now here in the mesh analysis, in the nodal and in the Thevenin's, in the superposition theorem, we got the same values, same for all the circuits. So Thevenin's, and first you compare these answers with Thevenin's, you will get idea about how theorems are verified. All theorems are same. You can use any theorem, you will get the same value. I hope all these things are clear to you. If you still have any doubts, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.